Let's verify that two functions are inverses of one another. We'll look at f of x equals negative 2x plus 5, and the other function we'll look at is g of x equals negative 1/2 times x minus 5. So the technique that we'll use to verify whether they're inverse functions is we'll use composition of functions. So we're going to test, or we're going to try f of g of x, and what we're looking for is to see, does this equal x? We're going to check that. And then we're going to look at g of f of x, and we're going to check to see, does that equal x? And if this composition of functions equals x and this composition of functions equals x, then we can say, sure enough, we can say that we have two functions that are inverses of each other. So let's go for it. Let's do a little math. So f of g of x looks like this. And in this case, our f is negative 2 times something plus 5. And our something is going to be g of x, so we'll put in there negative 1/2. And then we'll multiply that times x minus 5. And then when we multiply the negative 2 times the negative 1/2, a very common mistake that people make here is they believe that they're supposed to distribute. They believe they're supposed to multiply the negative 2 times the negative 1/2 and then multiply the negative 2 times some other stuff. And that couldn't be further from the truth. So please make a note right now. I'd love to see this in your notes, that this is not distribution. Instead, all we're doing is multiplying three things together. Negative 1/2 times x minus 5 and negative 2 times that. So what we can really do is use the associative property of multiplication that says that if we're just multiplying three things together, then we can group them any way we want and we'll get the same product. That means essentially what we really just have is negative 2 times negative 1/2 times x minus 5. Now, you don't have to take my word for it. Don't just believe me. Go and plug in a 3 for x, or whatever number, whatever you're comfortable with, 5 or 7, and evaluate this expression. I'm going to go ahead and circle it. Evaluate this expression right here, and then go ahead and evaluate this expression right here with that same value of x, and see if you get the same result. I believe you will. And then let's take it one step further. Now that we've done this, we can see that negative 2 times negative 1/2 is simply 1. So these two guys cancel. So what we really are left with is simply x minus 5 plus 5. That's all you get. And again, if you don't believe that this is the same as this is the same as this, plug in a number like 3 there or there or there, and see if all three of these have the same value. I say that they will. So in the end, negative 5 plus 5 is 0. So sure enough, we get the result that we were hoping for, is that if I take f of g of x, I get x. Now, let's try it with g of f of x. Let's see what happens. So we will say g of f of x is equal to negative 1/2. And don't forget that we've got to say that this is a big parentheses here, minus 5, and then parentheses again. That x just turns into a set of parentheses. So let's see here. So that'll be, we're going to put negative 2x plus 5 in these parentheses because we're putting f of x into g of x. So let's go ahead and multiply it out. Let's see. Now, in this case, we can use PEMDAS and we can simplify everything in parentheses before we do anything else. Since this is negative 2x plus 5 minus 5, We're just adding and subtracting, and because that's all that we're doing, we're allowed to remove the parentheses. Again, associative property of addition says if I'm just adding a bunch of things together, I'm allowed to throw away parentheses. So I'm going to rewrite this as negative 1/2, and then that's going to be negative 2x plus 5. And just to make it so it's kosher, see this minus 5? I'm going to make that plus a negative 5. That way I am truly just adding these two things together, and it makes it so that I feel really comfortable that it's legal for me to go ahead and use the associative property of addition here and throw away these two parentheses. Just say goodbye to those guys. That's the associative property. I can regroup things that are added together any way I want, and this is simply adding. I'm just minus 5 is the same as plus a negative 5. Okay, so let's go ahead. Now that I've got that, I'll do negative 1/2 times negative 2x plus 5 minus 5. That's just negative 2x. And then when I multiply again, I do not need to distribute this negative 1/2 times the negative 2 and negative 1/2 times x. It's unnecessary. There is no distribution here. Distribution only occurs when I have something times two things that are added together. Since that is not the case here, we're not gonna use distributive property. So say goodbye to the distributive property. Let's try another alternative. So what we'll do is we'll use associative property. And associative property of multiplication says if I have a bunch of things multiplied together, I can regroup them any way I want, and I still have the same product. And as a result, we couldn't be happier. Negative 1/2 times negative 2 gets us 1. 1 times x is simply x. Yay! We got the results we were looking for. We were hoping that f of g of x would be x, and it is. And we were hoping that g of f of x would be x, and it is. Therefore, we can make the statement in the end that these two functions are inverses. So I'm actually taking the time to write it out, and so should you. F of x and g of x are inverses. Yay! We proved it by doing composition of functions on one way and then composition of functions another way, and we got x each time.